On a Monday morning in March, Victoria Aldridge signed a 90-day contract with a man she called temporary. The factory she ran was bleeding money because a production line nobody could fix kept shutting down without warning. 3 engineering firms and 2 rounds of consultants had already failed to find the cause. The man she hired wore a canvas jacket and carried 30 years of knowledge in his hands that no monitoring system could read. What Victoria didn't understand was that the problem on her floor wasn't a broken part. It was 1,000 invisible relationships between moving pieces that only one man had ever understood from the inside out. The conference room on the 14th floor of Aldridge Manufacturing had the kind of silence that follows a decision already made. Victoria sat at the head of the table. She was 41, precisely dressed, and carried the particular confidence of someone who had never been wrong about anything that mattered enough to remember. Walt Harlow sat across from her. He was 62, and his hands rested on the table the way hands rest when they've spent 40 years holding tools instead of pens. The canvas jacket he'd worn had been washed so many times that the original color was a memory. Under his fingernails there was grease, not fresh grease. The kind that's been there so long, it's become part of the topology, the way a scar becomes part of the skin. The contract was 3 pages long. Walt read every word. Victoria watched him read the way a person watches someone fill out a form they consider unnecessary. She had already decided what this man was, a bandage. 90 days of manual labor on a problem her real resources had already proven unsolvable, after which he would leave and she would move on to the next solution. Gregson stood by the window, Victoria's VP of Operations, and his posture communicated exactly what his silence didn't need to say. He'd argued against this hire, not because he doubted Walt's ability, but because he doubted the category. A retired mechanic didn't belong on a modern factory floor. The floor ran on PLC systems and digital monitoring overlays, and what it needed was better software, not older hands. Victoria slid the contract across the table. 90 days, she said. You fix the line, you collect your fee, and we part ways, clean and simple. Walt signed his name in a hand that was steady and unadorned, the way a person signs something they intend to honor but don't consider important enough to celebrate. I'll need access to the floor before the morning shift, he said. Before the machines are running, you'll have it, Victoria said, and the meeting was over. Walt reached into his shirt pocket and touched the edge of a folded piece of paper. His daughter had given it to him that morning, a crayon drawing of a man standing inside a big machine. Lily was 8 and she had told him the man was him. He kept it in his pocket because when a child hands you something she made, you carry it. Before he had signed, he had read the factory's specification sheets and the fault code history Victoria's team attached as an appendix. The engineering firms had read the same codes and concluded the line was experiencing random sensor failures. Walt had looked at those codes and seen something different. Not a pattern in the codes themselves, but a pattern in what was missing from them. Sensors reading within tolerance and machines stopping anyway. Systems reporting nominal and production declining. A factory monitoring itself correctly and failing anyway. That was not a sensor problem. That was a calibration problem. The sensors were reading about the wrong thing, and somewhere in the gap between what the spec said and what the machine was actually doing, the real problem was hiding. The question was how deep that gap went and whether the system built to monitor this factory was capable of seeing anything that lived inside it. He did not say any of this to Victoria. A diagnosis made in a conference room is worth nothing. A diagnosis made with your hands on the machine is worth everything. He started the truck and drove home. Walt arrived at Aldridge Manufacturing at 5:15 the next morning, 45 minutes before the first shift. The factory floor was enormous and precise. The concrete was sealed to a mirror finish. The lighting was the controlled, colorless illumination of spaces designed for accuracy rather than comfort. The air carried the faint mineral smell of lubricant, and the particular hum of machines waiting to be turned on, the sound of potential energy sitting still. The production line ran the length of the building in a configuration that a team of process engineers had optimized 3 years ago. 7 stations, each one feeding the next, each one monitored by a PLC system that reported uptime, throughput, defect rate, and thermal data to a central dashboard on the second floor. Every sensor, every motor, every actuator was tagged and tracked. The system knew where every part was, how long it had been there, and whether it was performing to specification. The line was also running at 60% capacity, and it had been for 7 months. Walt walked the floor alone. He did not start with the machines. He started with the spaces between them, the paths the operators walked, the distances between stations, the way the floor showed where in some places and not others. Where the operators walked told him what they avoided. Where the concrete was worn told him where they stood. Where the paint was scuffed near a control panel told him which buttons they pressed most often and which ones they never touched at all. He stopped at Station 3 and placed his hand on the motor housing. He closed his eyes. The motor wasn't running yet, but the housing carried the residual warmth of yesterday's operation, and warmth carries information the way a voice carries words. He felt the vibration pattern in the metal, the faint harmonic signature of a machine that had been running slightly off its axis for a long time. Not enough to trigger a fault code, not enough to appear on any diagnostic, but enough that an operator standing next to it 8 hours a day would learn to compensate, without knowing they were compensating, the way a person walks differently on a leg that aches without ever deciding to limp. He moved to Station 4. Same procedure. Hand on the housing, eyes closed. The thermal regulator assembly sat inside a steel enclosure at the base of the station, and when Walt touched the enclosure, he felt something that made him open his eyes and look at it for a long time without moving. An operator named Dell was setting up at Station 6. He was 58 with the kind of face that had spent 30 years under fluorescent lights, and he was watching Walt with the particular attention of a man who recognizes something he hasn't seen in a while. Dell had worked at Aldridge for 22 years. He had been on the floor when the old line ran, before the automation overlay was installed, and he remembered what it sounded like when a machine was running right. He did not hear that sound anymore. Gregson appeared at 7, crossing the floor with the purposeful stride of someone who wanted to be seen arriving. He introduced Walt to the floor staff with a sentence that landed like a label. "This is Walt Harlow, our temporary consultant." The word temporary carried. It carried the way a word carries when it is chosen specifically to limit the scope of what follows. Walt did not react. He had been called temporary before. He had been called worse. He shook Dell's hand and felt the calluses that matched his own, and he nodded at the other operators the way a person nods when they understand that the people standing in front of the machines know things. The people standing in front of the dashboards do not. He spent the rest of the morning walking the line with his hands, station by station, housing by housing, feeling the residual vibrations, the thermal signatures, the places where the hum was right and the places where the hum was wrong. He did not take notes. He did not consult the dashboard. He let the machines tell him what the monitoring systems could not, because the monitoring systems were listening for problems that fit inside their programming, and the problem on this floor did not. By noon, he knew what he was looking at. The question was not whether he could fix it. The question was whether anyone would let him. The sensor at Station 3 was reading within tolerance. Every diagnostic confirmed this. The PLC logged its output as nominal, the dashboard displayed it as green, and the automated monitoring overlay that Gregson's team had installed 2 weeks earlier reported no anomalies. By every measurement the factory's systems were designed to capture, the sensor was fine. Walt knew it was not fine. The sensor was a proximity detector, calibrated to confirm that a component had seated correctly in its fixture before the next station could advance. The specification called for it to detect position within a tolerance of 0.03 of a millimeter. At ambient temperature, it did exactly that. Clean readings, zero drift, perfect alignment with the spec sheet. But the factory didn't run at ambient temperature. It ran at operating temperature. which was 41 degrees Celsius higher after 2 hours of continuous production. And at that temperature, the sensor's detection threshold drifted, not outside its rated range, not far enough to trigger a fault code, but far enough that it began accepting components that hadn't seated correctly, passing them to the next station with a green light and a clean log entry, while the component sat in its fixture with a gap too small for the sensor to see and too large for the next station to work with. This wasn't a broken sensor. It was a sensor doing exactly what it was told, reporting accurately about parameters that didn't match the reality of the machine it was attached to. The monitoring system wasn't wrong. It was deaf to the specific frequency at which the problem spoke. Walt fixed it by hand. He disconnected the sensor, opened its calibration housing, and adjusted the detection threshold to compensate for the thermal drift that occurred under actual operating conditions. He did not replace the sensor. He did not install a more expensive unit with a wider range. He tuned the one that was there, the way you tune an instrument that is playing the right notes in the wrong key. The fix took 40 minutes. He worked with the particular concentration of a man who does not think about time when he is working on something that matters. Dell watched from Station 6. The other operators watched from their stations. Nobody came over to ask what he was doing. After the recalibration, Walt ran a test cycle. The sensor caught two components that had previously passed through undetected, flagged them correctly, and stopped the line until they were reseated. The fault code for those components appeared in the system for the first time. The dashboard logged two new anomalies that hadn't existed before Walt's adjustment because the system had never known they were happening. Gregson's engineering team reviewed the fix that afternoon. Their report noted that the recalibration was undocumented, that it deviated from manufacturer specifications, and that a manual adjustment couldn't be validated by the automated monitoring overlay. They classified the result as anecdotal and recommended that the sensor be returned to factory calibration. Victoria saw the report. She also saw that throughput at Station 3 had increased by 18% overnight. She told Gregson to leave the sensor alone for now, but to keep watching. Walt did not file a response to the engineering report. He moved to Station 4, where the real problem was waiting, and where one drifting sensor had already begun to reveal something much larger. Station 4 was where the thermal regulation assembly lived, and it was where the real problem started. 4. The drift at Station 3 had been causing something that no one had traced before, because no one had looked at the relationship between stations in the right order. The sensor passing slightly misaligned components had created a timing mismatch in the assembly sequence at Station 4. The components arrived at Station 4, a fraction of a second off their intended schedule, and that fraction was enough to change the load profile on the mechanical coupling that drove the station's primary actuator. The coupling was rated for a specific load range. The timing mismatch pushed the load just outside that range, not enough to break the coupling, but enough to stress it in a way it was never designed to handle. Stressed under load, the coupling transferred excess vibration to the bearing housing that supported the station's drive shaft. The vibration was subtle, the kind that shows up as a faint harmonic in the housing's resonance, too quiet for any sensor to catch, but loud enough that a hand on the metal could feel it, the way you can feel a train coming before you hear it. The excess vibration generated heat in the bearing housing, not enough to trigger the thermal sensor, but enough to change the operating temperature inside the thermal regulator assembly that sat directly below it. The regulator was degrading. Over months of exposure to a heat source it was never designed to manage. Its calibration shifted, allowing the station's internal temperature to drift upward by fractions of a degree per week. The PLC monitoring the regulator read its output as nominal because the regulator was still within its programmed tolerance band. But the tolerance band was wrong, and nobody noticed because the monitoring system said everything was fine. This was the Cascade. Not a single failure, but a chain of small deviations, each one invisible on its own, each one causing the next, each one compounding, until the cumulative effect was a production line running at 60% capacity while every diagnostic in the building reported nothing was wrong. Walt fixed the coupling first. He adjusted its alignment by hand, compensating for the timing mismatch rather than trying to eliminate it at the source, because the source was the sensor at Station 3, which he had already fixed. With the sensor recalibrated, the timing mismatch would resolve itself over the next production cycle, but the coupling had been running under stress for months and needed to be reseated. Then he replaced the bearing. Not because it had failed, but because it had been running under abnormal load for long enough that its service life had been cut in half. A bearing that should have lasted 3 years would now last 18 months, and the only way to know that was to hold the old bearing in your hand and feel the wear pattern in the race, the particular roughness that tells you a component has been living outside its design envelope without ever telling anyone about it. Then he addressed the thermal regulator, the component at the center of the Cascade and the fix that would matter most later. He opened the calibration housing, removed the factory set module, and installed a hand-tuned replacement he had machined on a small lathe in his garage the night before, working by the light of a single fluorescent tube while Lily slept in the next room. His calibration accounted for the actual thermal environment inside Station 4, not the theoretical one in the specification. It compensated for the excess heat, adjusted for the drift, and set the regulator's response curve to match the machine's real behavior rather than its rated behavior. The fix took most of a day. He was done. He ran the station through a full production cycle, and for the first time in 7 months, Station 4 completed an 8-hour run without a single anomaly. Gregson noticed that Walt was bypassing the standard change control procedures. He filed a formal note in the operations log, contractor making undocumented modifications to production systems. The note included a recommendation that all future modifications be submitted through the engineering review process and approved before implementation. Victoria saw the note. She did not stop Walt from working. She told Gregson to monitor him closely. The house was small and set back from the road behind a gravel driveway that filled unevenly when it rained. The garage held more tools than it did cars. The kitchen smelled like coffee and oatmeal, and the light above the stove had a flicker in it that Walt had been meaning to fix for 3 months and hadn't gotten around to yet, because a flickering kitchen light is the kind of thing a man puts below the things that matter. Lily sat on a stool in the garage while Walt worked on an old lawnmower engine. She was 8, with tangled hair and serious eyes, and she asked questions the way children do when they are genuinely curious. "How does it know when to spark?" she asked. "It doesn't know," Walt said. "The spark happens because the magnet passes the coil at the right time. It's just positioned." He handed her a feeler gauge and showed her the gap between the armature and the flywheel. "This gap, it has to be this wide. Not wider, not narrower." Lily held the gauge carefully and measured the gap. "It's too wide," she said. "That's why it wasn't running right. Go ahead and tighten it down." She turned the screw with a small socket wrench, watching the gap close until the gauge slid through with just the right amount of drag. She looked up at him with the particular satisfaction of someone who has done something that works exactly the way they were told it would. "The gauge tells you the truth," Walt said. "The machine can't lie to the gauge." Lily pulled a folded piece of paper from the pocket of her jacket, which was too big for her and had been his before she claimed it. It was a drawing, a man standing next to a lawnmower, and next to him a small figure holding a silver tool. Above the man's head, she had drawn a sun with 8 rays. "That's you, and that's me," he said, "and that's the gauge." Walt folded the drawing and put it in his shirt pocket next to the other one. He did not say anything about it because some things don't need to be said, they only need to be done. The contract paid enough to cover the house payment and the braces Lily needed. That was why he took the job. Not ambition, not vindication. A man who has spent his life fixing things does not stop just because the world has decided it no longer needs him to hold a wrench. He keeps working. He keeps showing up because that is what a father does when the room is dark and no one is cheering. By day 40, the production numbers on Victoria's dashboard had begun to climb. Throughput was up 22% from the baseline. The defect rate had fallen to its lowest point in 2 years. Uptime, which had been hovering around 60% for 7 months, was now crossing 80%, and the trend line was still pointing up. Victoria saw these numbers in her morning briefing, and she credited the improvement to the new automated monitoring overlay that Gregson had installed in the second week of Walt's contract. The overlay had been designed to provide real-time diagnostics across all 7 stations, and its implementation had coincided exactly with the period when Walt's manual fixes were beginning to hold. In Victoria's framework, improvements came from systems. The overlay was a system. The overlay was new. The numbers were better. The conclusion wrote itself. She did not connect the improvement to Walt because, in her understanding of how a factory worked, a retired mechanic did not produce measurable improvements. A retired mechanic performed manual tasks. Measurable results came from technology, from process optimization, from the kind of analysis that appeared in engineering reports and could be tracked on dashboards. Walt's work did not appear on the dashboard. Walt's work existed in the physical adjustments he had made to components that the dashboard reported as unchanged, because the dashboard did not know they had changed. The machines were running cleanly because Walt's calibrations were holding. The overlay was reading good numbers because Walt had made the numbers good. The system was monitoring a machine that a man had fixed, and the system was receiving the credit for the fix. On the floor, the operators knew the truth. They had watched Walt work. They had seen production runs finish without interruption, something that hadn't happened in months. They had felt the difference in the machines, the way a house feels different after the foundation has been repaired and the doors close properly again. Dell came to Walt directly with a problem he had been reporting through channels for 3 weeks. A vibration in Station 7 that appeared intermittently during the second hour of the afternoon shift. Dell had filed 3 reports. The vibration did not appear on any diagnostic because it fell below the monitoring system's detection threshold, and the reports had been closed with the notation, "No anomaly detected." Walt listened to Dell describe the vibration, and then he went to Station 7 and placed his hand on the housing. He felt it immediately a shaft alignment issue that was causing a resonance at a specific RPM that occurred only during the second hour of the afternoon shift, when the line had been running long enough for thermal expansion to shift the shaft's position by exactly enough to create the vibration Dell was hearing. It was the same principle as the sensor at Station 3, the same pattern, a problem that existed inside the machine's actual behavior, but outside the parameters the monitoring system was programmed to observe. He fixed it that afternoon. A 30-minute adjustment to the shaft coupling. He showed Dell what he had done and why, and Dell nodded in the way that a man nods when someone explains something he already suspected but couldn't prove. Walt wrote a technical memo that evening. He described the thermal variance pattern he had discovered across multiple stations, the specific combination of load, runtime, and ambient temperature that triggered the cascade, and the calibration adjustments he had made to compensate. He wrote it in plain language, the way a person writes when they are trying to communicate rather than impress. He submitted it through channels the next morning. Gregson's team received the memo and filed it under anomalous readings. It was not distributed to the engineering staff. It was not attached to any operational review. It entered the system and disappeared, the way useful information disappears inside systems that were not designed to carry it. And that disappearance would matter more than anyone on that floor yet understood. The tension on the floor was becoming visible. Walt was holding the factory together with his hands while the system that employed him refused to see what his hands were doing. The operators saw it. Dell saw it. The machines saw it in the way machines see things, by running correctly for the first person who had listened to them in years. But the dashboard didn't see it, and the dashboard was what Victoria watched, and what the dashboard couldn't see didn't exist. And a system that cannot see the thing keeping it alive is a system that will eventually remove it. Day 85. Gregson found it during a routine systems audit. The thermal regulation assembly at Station 4 was running on a hand-calibrated module that did not match any entry in the factory's component registry. It had been installed without a change control ticket, without engineering review, and without approval. In Gregson's framework, it was an unauthorized modification to a critical production system. He walked to the station and opened the housing. Inside, a component clearly not factory issue, smaller than the OEM module, machined from a different alloy, calibrated by hand. The tolerances were tighter than the specification required, and the response curve compensated for thermal conditions the factory's design documents did not reference. Gregson did not see a fix, he saw a liability. The factory had a PLC-controlled thermal management module installed 6 months earlier as part of the automation upgrade designed to replace manual calibration entirely. It monitored thermal conditions in real time and adjusted dynamically. It was the modern solution. The module was also disabled 3 months ago because it couldn't match the performance of Walt's hand-calibrated component. Under Walt's calibration, the regulator held the temperature within a band that allowed every downstream system to function at full capacity. Under the PLC module, the programmed band was wider than the station actually needed, and the downstream systems ran at reduced efficiency. Gregson saw this not as evidence that Walt's calibration was better, but as evidence that the PLC module needed recalibration through proper channels. He filed a change request proposing to replace Walt's component with the PLC module, and he attached Walt's own technical memo, the one about anomalous readings, as evidence that Walt's approach was based on unverified observations rather than engineering rigor. Walt went to Victoria's office and explained in specific technical terms what would happen if the PLC module replaced his calibration. The module was programmed for steady-state thermal management. It adjusted within a range that assumed the thermal environment behaved according to the factory's design specifications, but the actual environment didn't. It behaved according to a pattern that only emerged under full production load after approximately 3 hours, when accumulated heat from the bearing housing combined with the upstream timing mismatch to create a thermal signature the PLC was never designed to manage. Victoria heard Walt describe a problem that didn't exist in any engineering report, documented only in a memo filed under anomalous readings, and contradicted the specifications she'd paid 3 firms to validate. She heard a retired mechanic telling her that her automated system wasn't good enough, and she couldn't verify his claims against any independent source. She'd invested heavily in that system. Backing Walt over it would mean acknowledging the investment had failed. She backed Gregson. The override was approved. Walt returned to the floor. He walked to Station 4, opened the housing, and removed his hand-calibrated component. He held it for a moment, turning it in his fingers. He had machined it from brass stock on his lathe at home, cutting the calibration profile by hand, adjusting the tolerances with a micrometer and jeweler's files, until the curve matched exactly what the machine needed. 4 hours to make. 11 weeks without a single anomaly. He wrapped it in a shop cloth and placed it in his toolbox. Then he installed the PLC module, connected the wiring, and seated the unit. He did this carefully, precisely, the way a man does a job he's been ordered to do by someone who doesn't understand it. He did not sabotage the work, he did the work correctly. Before he closed the housing, he placed his hand on the metal one last time. He felt the PLC module initializing, the quiet vibration of a system doing exactly what it was told. He felt what the system couldn't. The thermal variance already building in the bearing housing above. The slow accumulation of heat the PLC's programming didn't account for. The cascade that would begin in approximately 3 hours under full production load and wouldn't stop until the entire line came down. He knew it was coming. Not the hour, but the conditions. Full load, 3 hours in. The variance the PLC couldn't see because no one had told it to look. And when it came, it wouldn't stop at one station. It would take the entire floor with it, because every fix Walt had made was now undone, and the cascade he'd held back for 11 weeks was about to run through the factory like water through a broken dam. He closed the housing and walked away. Day 87. The production run started at 6. The PLC module at Station 4 initialized cleanly, reported nominal, and began managing the thermal environment according to its programmed parameters. For 3 hours, everything looked right. At 9:07, the thermal variance pattern emerged. The accumulated heat from the bearing housing reached a threshold the PLC's programming did not recognize. The module saw a reading within its programmed tolerance band and adjusted accordingly, but the tolerance band was wrong. It had always been wrong. The regulator failed to respond, not because it was broken, but because it was doing exactly what it was told, and what it was told wasn't enough. The cascade began as a drift. The station's internal temperature climbed past the point where downstream electronics could function at full capacity. Sensors at the next station flagged components arriving out of specification. The defect flag triggered an automatic slowdown upstream. The slowdown changed the load profile on the conveyor assembly, which could not adjust to the reduced flow without creating a backup. The backup triggered a work-in-progress overflow, which activated emergency stops at stations 4 and 5, which signaled the central PLC that a cascade event was in progress. In 11 minutes, a production line running at 80% was running at 0. The factory floor went quiet, not the quiet of a planned shutdown with its countdown timers and reassuring green indicators. The quiet of a machine that has stopped against its will. Operators stood at their stations waiting for instructions that did not come. The dashboard displayed red indicators spreading across the production map like a slow explosion. Gregson scrolled through fault codes with both hands, unable to find the root cause because every code pointed to a different station and every station reported a different failure. The codes didn't make sense because the cascade wasn't a single failure. It was the result of small deviations that had been held in check by Walt's manual calibrations and were now running free. Each station failed in its own way, for its own reason, but all the reasons traced back to one source. The thermal regulator at Station 4 was no longer managing the environment the cascade required. The consultants restarted the system 3 times, and each time the line ran for approximately 19 minutes before the variance reappeared and the cascade began again. 19 minutes was not enough for the heat to build. 8 hours. Victoria stood in the doorway of the floor office and watched the still line, the motionless conveyor, the operators sent home, and she understood something the data could not tell her. The man she'd called temporary had been holding this factory together with his hands, and she'd let someone take his hands off the machine. Day 89, dawn. Victoria drove to the address listed in the contractor file. The house sat at the end of a gravel driveway behind a patch of bare lawn, small and neat, the kind of place a man settles into when he's stopped expecting more than he needs. The garage light was on. Through the open door, she could see a man in a canvas jacket working at a bench and beside him on a stool. A small girl watching. She stood in the doorway. The smell of engine oil and old wood. The quiet sound of metal on metal. The particular quality of light in a workspace that has been used for decades. Walt looked up. He didn't seem surprised. He set down the tool and wiped his hands on a cloth. "Morning," he said. "Morning," Victoria said. Lily looked at the woman in the doorway, wearing a coat over business clothes, with the kind of face used to being in charge of rooms. Victoria's eyes moved to Walt's shirt pocket. The edge of a folded piece of paper was visible there, and she recognized it as a drawing. The paper was the kind children use, slightly thicker than office paper, with the faint texture of crayon at the crease. She had one like it on her own refrigerator from her nephew. The difference was that Walt's was in his pocket because he carried it, not because he displayed it. "I need you to come back," Victoria said. Walt looked at her for a long moment, not weighing options or calculating leverage. Just looking at her the way a person looks at someone who has arrived at a conclusion they could have reached much earlier if they'd been willing to see what was in front of them. "On what terms?" he said. "I'll extend the contract. Full rate however long you need." No, the word was quiet and final. Way a person states something that is simply true. "More money then. Name a number." "It's not about money." "What's it about?" Walt set the cloth down and looked at his hands for a moment. The next person you hire to do this work needs to be allowed to do it the way it needs to be done, not the way the dashboard says it should be done. The monitoring system you trust is reading the wrong language. The machines are speaking, and the system is deaf to what they're saying. Until you understand that, no contract extension and no amount of money will keep that line running. Victoria didn't argue. She stood in a garage that smelled like engine oil and patience, looking at a man whose hands had fixed what 3 firms and 2 rounds of consultants could not. And she understood that the expertise she had treated as temporary was the only permanent thing her factory had. Agreed, she said. Walt nodded once. He picked up his toolbox, and the drive from his garage to the factory floor was the shortest distance he had ever traveled between 2 points, because every minute the line stayed down was a minute the company could not afford. Walt returned to the factory floor at 7 that morning. He did not call a meeting or give a presentation. He walked directly to Station 4, set his toolbox on the floor, and opened the thermal regulator housing. The PLC module sat inside, managing the thermal environment according to parameters that did not match the machine's actual behavior. Walt disconnected it, removed it, and reached into his toolbox for the shop cloth containing the hand-calibrated component he had machined 11 weeks ago. He installed it, connected the calibration leads, and began the work of adjustment. 4 hours. Worked by feel and by sound, adjusting the calibration profile in increments no micrometer could measure. He was adjusting by ear, by vibration, by the particular resonance a correctly calibrated regulator produces when it is managing the exact conditions it was designed for. Operators gathered around the station. Dell stood closest, handing Walt tools without being asked. Victoria watched from the floor office. She didn't check the dashboard. She watched his hands, and for the first time she understood that what those hands carried couldn't be replaced by any system she'd ever buy, because what they carried wasn't a technique or a procedure. It was knowledge, and knowledge that lives in hands doesn't transfer through reports. After 4 hours, Walt closed the housing and asked Dell to initiate a full production run. The line started. The stations engaged one by one. After 3 hours, the thermal variance pattern emerged. The hand-calibrated component adjusted because Walt had built the adjustment into the calibration itself. He had machined the response into the physical properties of the component so that when thermal conditions reached the threshold, the regulator shifted its curve automatically, without software, without code, without a dashboard telling it what to do. The line ran clean. Victoria stood in the doorway of the floor office, and the red indicators on the dashboard behind her had gone green one by one, and she didn't move for a long time. Walt packed his tools that evening. His 90 days were up tomorrow. He wouldn't stay. Not because he was punishing her, but because he was always going to leave. This was a 90-day job, and he had finished it. Before he left, he spent 1 hour with Dell and another floor operator named Reyes, who was 34, and had the kind of hands that might learn what Dell's and Walt's already knew. He showed them the calibration points on the thermal regulator. He let them feel the vibration pattern with their hands on the housing. He taught them what to listen for, the specific harmonic that meant the regulator was adjusting correctly. He placed their hands on the metal and guided them to the frequency, the way his father had guided his hands 40 years ago. Not with a manual, not with a procedure, with patience, and with the particular trust that exists between a person who knows something and a person who is ready to learn it. He drove home at 7. Lily was waiting at the kitchen table with a new drawing. He unfolded it. A man standing outside a machine this time, with a small girl beside him, both of them smiling. Above them a sun with 8 rays. He folded it carefully and put it in his shirt pocket. Walt left on day 90. The line ran clean for 3 more years because he had trained 2 operators the way his father trained him. Not with manuals, but with patience and time. Some knowledge only moves through hands. If you believe character is what a man does when no one is watching, subscribe to Dad Legacy Justice.